Assalamualaikum and hi. We are from Group 1 from Section 2 of the BFP40603 Industrialised Building System course. Our group members are Elvin, Ko, Nur Arisa, Alia and myself, Sophia. Today we will be presenting our community development proposal using the Industrialised Building System or IBS for a remote orang asli in settlement located in Perak. Our project focuses on addressing the lack of infrastructure in a remote orang asli village due to its isolation, dense forest and hilly terrain. Traditional construction is both difficult and inefficient. The community lacks key facilities like a multipurpose hall and kindergarten, which impact a social engagement and education and early education. To address this, we propose using IBS methods for efficient and sustainable development. Our main objective are to design and construct a sustainable multipurpose hall and kindergarten using IBS. We aim to create an inclusive space for growth while demonstrating that IBS is effective in remote area. Our projects include site selections, component integrations, logistic planning and ultimately achieving a high IBS score aligned with CIDB standards. Our main objective are to design and construct a sustainable multipurpose hall and kindergarten using IBS. We aim to create an inclusive space for growth while demonstrating that IBS is effective in remote area. Our projects include site selections, component integrations, logistic planning and ultimately achieving a high IBS score aligned with CIDB standards.
Now, I will present about transportability. IBS is highly suitable for orang asli settlements, which are often hard to access using conventional methods. Unlike traditional construction, IBS reduces the need to transport loose material like cement, sand and bricks. The third one, prefabricated components are stackable and compact, enabling fewer trips and easier logistics. And the last one, less transportation means lower costs, reduce traffic disruption and decrease carbon emission during construction. The next part is community needs. The first one, IBS speeds up construction by using prefabricated component, allowing urgent facilities like multipurpose hall and kindergartens to be completed much sooner than traditional methods. Minimal noise, dust and disturbance from IBS assembly help maintain community comfort during construction. And last one, off-site fabrication and on-site work can proceed simultaneously, significantly cutting down total boot time. Next part is sustainability. Off-site prefabrication reduces material waste significantly compared to traditional methods as it allows for precision cutting and controlled production. Faster on-site assembly decreases the use of heavy machinery and transport vehicles, reducing energy consumption and carbon footprint during construction.
Hi, my name is Elvin. So next will be the 2D layout drawing, which is a site layout plan. You can see that the site location is at Kampung Orang Asli Postegat, Sungai Sibu, Perak. So this is the 2D layout architecture drawing for multipurpose hall, which is the ground floor plan. This is the first floor plan. And these are the elevation plan for the multipurpose hall. This is also the section plan for the hall. And also this is a structure plan for the multipurpose hall, which is the ground floor key plan. And this is the first floor key plan. And next will be the 2D layout drawing for the architecture plan of the kindergarten building. This is the elevation plan. And also this is your structural plan. And next will be the 3D modeling and IBS component. So this is the 3D view of the community hall, and which is built by using the Autodesk Revit software. So you can see that there are the details, which is the detail level in the 3D view. And this is the 3D modeling for the kindergarten building, also attached with the detail leveling in the view. So for the IBS component, firstly will be the frame system. So detail A is the skeletal frame system. So this system comprises the modular components such as precast columns, beams, and staircase, and also the walls. So this is applicable to both multipurpose hall and kindergarten buildings. For detail B is the portal frame system. So this system utilizes large precast and steel assembled columns and rafters rigidly connected to form the moment resisting joint capable of spanning wide distance without intermediary support. So this is applicable to the multipurpose hall.
Now I will explain about the connection system. For the first one is detail C, which is double shear connection and beam to column. Focus for the details. This detail is efficiently transfer vertical and horizontal load between precast component. The component is the first one, 3D steel bar, transfer shear force horizontal. The second one is cobble, act as a shock cantilever to support vertical loads. The third one is precast beam, sits on neoprene pad over cobble. The fourth one is neoprene pad, reduce stress concentration and allow slight movement. And the last one is coating, freeze the vertical hall partially to lock the bar in place. These are detail applicable to both multipurpose hall and the kindergarten building. Second one for the connection system is detail D, which is grotted sleeve column to face. The key concept is the first one, grotted sleeve, join precast column by inserting rebar into steel sleeve filled with high strength grout. The second one is load transfer, efficiently handles axial shear and bending force. For the feature shown in figure, for picture A schematic, show rib bar inserted into sleeve with grotting and overflow holes for complete bonding. The picture B is set image, real life view of grotted sleeve connecting during rebar installation. This detail applicable to both multipurpose hall and kindergarten buildings. Third one is detail A, which is bolted connection. connection column to base also. The key features: the steel base plate is connected to the column end and anchored to the concrete foundation using bolts. Transfer axial load, shear force, and bearing moment into the ground safely. Provide a rigid and stable support for vertical and lateral loads. What the figure show is diagram illustrate a column to foundation connection with base plate, bearing space, anchor bolts, and foundation anchor plate. Steel packing and clearance hall ensure proper load transfer and easy installation on site. This one is applicable to multi-purpose hall. The last one for the connection system is detail F, which is welded connection, general connection, hole steel. What is welding? A common method to join steel component by melting and fusing metals. Use bolts in fabrication shops and on construction site. Create rigid monolithic joints with strong continuity. Application infrastructure, which is essential in steel building frameworks and bridge construction. Ensure high structural integrity and efficient load transfer. And last one, suitable for permanent connection that requires strength and durability. This one applicable to multi-purpose hull. For the picture, the A is a butt joint, the B1 is a longitudinal joint, the C1 is butt joint, D is quarter joint, H1, E is edge joint, F is transverse fillet joint, and G transverse fillet joint, H is joint, and the last one I is corner joint 2.
So next will be the floor system. So there are two types of slab that will be used in the both of the community hall and also kindergarten building. So for the detail G is the precast hollow core slab, which is top. So these hollow core slabs are widely utilized in modern construction due to their lightweight nature, structural efficiency, and cost effectiveness. And also for detail H, which is the precast plank. So the precast plank floor system is the composite construction method that integrates the precast concrete planks, steel reinforcement mesh, and also cast in situ concrete topping. So next will be the structural tie system. So detail I will be the internal floor tie, which is the horizontal tie. So it provides effective tying action between adjacent precast slab units, especially at their end to prevent the differential movement and displacements. So for detail J is the perimeter floor tie, which is also the horizontal tie. It provided along the edge of the floor slab to connect the end of precast floor unit. For detail K is the peripheral beam tie, which is a horizontal tie also. So it plays around the perimeter of the floor slab, connecting the floor units to H beam, external wall or columns. For detail L is the column tie, which is the first vertical tie. It ensures the vertical continuity and also improve the robustness of precast concrete structure. So these are the wall system used. Detail M, which is a light gauge steel frame panel LSF. So it has many advantages, including the resistance to mold and termites, high strength to weight ratio, easy fabrication, and also easy installations. For detail N will be the precast concrete sandwich panel. So it has both inner and outer layer made of concrete material that make it unique and distinctive compared to the structural insulated panels. So this is the wall system. Detail O is the block work system. So it's a versatile method of construction that involves the use of concrete block, cables, and lightweight blocks. So next will be the roof system. So for detail P, lastly will be the prefabricated roof front systems, which involves the factory manufactured trusses, usually made of lightweight steel or treated timber, which is pre-engineered, quality control, and also delivered to site ready for installation.
My name is Kobe Kwa. I will present Chapter 4, IBS score calculation. IBS score consists of 3 parts: Part 1, structural system; Part 2, wall system; and Part 3, simplified construction solution. 4.1, IBS score of multi-purpose hall. For structural system, we use precast column, beam, and slab. For B, we use cast in situ using reusable formwork for the slab near the staircase. For roof, we use prefabricated steel. The total score for Part 1 is 48.78%. For wall system, we use blockwork system for all walls except a brick wall system at the toilet, and the total score for Part 2 is 19.06. For Part 3, we select the standardized components that are aligned with IBS requirement. Therefore, this part we got maximum score 16 points. The multi-purpose hall have no repetition horizontally or vertically. Hence, there is no score for repetition of structural layout. For productivity, enhancing solution, and technology adoption, the score recorded is 13 points. Total score for Part 3 is 29%. By sum up the Part 1, Part 2, and Part 3 score for the multipurpose hall, the total IBS score for the multipurpose hall is 96.84%. 4.2, IBS score of kindergarten building. For structural system, we use precast column, beam, and slab. For B, we use cast in situ using reusable formwork for the slab near the staircase. For roof, we use prefabricated steel. The total score of Part 1 is 48.23%. For wall system, we use prefabricated wall panels for all walls except brick wall system at the toilet. The total score of Part 2 is 17.41%. For Part 3, standardized components utilization, kindergarten building score 16 points, and this building have horizontal repetition of structural layout that is 66.67%, hence it has scored 3 points. For productivity enhancing solution and technology adoption, the score recorded is 14 points. The total score for Part 3 is 30%. By total up the score recorded in Part 1, Part 2, and Part 3, the kindergarten building have the total IBS score of 95.64%. IBS score of the project. The IBS score of the project is calculated based on the coverage and also the IBS score of that building. So for building 1 multi-purpose hall, the IBS score recorded is 35.84%, and for building 2 kindergarten building, recorded 60.25%. Sum up these two values, we will get the IBS score of the project is 96.09%.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Ali Adrana binti Muhammad Faizal. My metric number is AF210060. So today I'm going to discuss the Industrial Building System IBS construction process that's starting with the offsite phase. This phase begins with the design and planning and followed by the prefabrication of components at the factory. Quality control inspection at the factory is a very important that will lead to the transportation to the construction site and on-site component storage. To the on-site phase, the process begins with the site preparation and foundation works. Next is the installation of structural components, then wall panels and roofing. This is followed by the mechanical, electrical and plumbing integration and finishing works. The phase concludes with the final inspection and handover. Let's start detail by detail for the off-site phase. First is design and planning phase. The process started with the architectural and structural conceptualization by using BIM tools. And then for the second one is shop drawing production, which is this phase need to shop the drawing detail every component, which are columns, beam and wall panels, stairs with the exact dimension, material specification. And next is off-site prefabrication of IBS component, which are conducted in climate control factory to minimize the defects. Next, following the off-site phase is factory quality control and testing, which reduce risk of the structural failure and improve life cycle performance. Next is logistic transportation, which is the delivery is optimized to minimize the congestion and prevent storage damage. And we are moving to the on-site phase, which is first is soil preparation and foundation work that needs the soil bearing test and geotechnical reports to determine required acidification and compaction to the site. Moving to the second one is on-site storage and handling of prefabricated elements, which is when the delivery happens, the IBS components are sorted by the type of elements and labeled clearly. And then next is the assemble of structural components, which means that structural elements are carefully aligned based on the layout plan. So this is very important as the precision to ensure the structural stability. Next is installation of wall panels, staircase and roof structures, as the panels are hosted using tower or mobile cranes to install the prefabrication. Then moving forward to the fifth step, which is installation of MEP system, which are precast modules. The precast of IBS element ensures that to reduce the on-site coordination time, that makes fewer installation errors and higher fire safety compliant that based on CIDB. The sixth one is internal and external finishing works, which is that makes external skim coating, waterproof paint and grouting of joints are performed at construction sites. And the final last step that concludes from everything construction process flow is final inspection, testing and handover. The final inspection cover load testing and structural soundness, MEP operation, which are water pressure and electrical grounding, and fire exit checks and accessibility audits. That's all from me for the construction process flow from off-site phase and on-site phase. Thank you very much.
In conclusion, our project aims to uplift the Orang Asli community by providing the vital infrastructure through modern construction solutions. With IBS, we can overcome the location-based challenges, deliver quicker results, and maintain the quality and sustainability. We hope this proposal highlights how engineering solutions can drive social development even in the most remote areas. That's all from us. Thank you.